Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Dr. Kiki's Science Hour is provided by CacheFly at CACHEFLY.com.
This is Dr. Kiki's Science Hour with Dr. Kiki Sanford and Leo Laporte, episode number 31 for Friday, January 22nd, 2010, Exploring Saturn's Moons. Welcome, everybody. This is Dr. Kiki's Science Hour, episode number 31 for Friday, January 22nd, 2010. And today we are going to be exploring Saturn's moons. Ooh, Saturn's moons. We're going to be talking about the Cassini mission and the moon Titan most of all, I believe. But joining us on the show, we have Dr. Rosaly Lopes, and she is a prominent planetary geologist. She's a volcanologist, not a volcanologist. And she's written all sorts of papers and books, and she talks with people all the time about the joys of watching planets grow and change and trying to get people to appreciate the science that goes into geology and what makes planets. So I'm extremely pleased to have her here on the show today. And so today, also in talking about the Cassini mission and the Huygens probe, we sent these things to Saturn to investigate the planet, the rings of Saturn, the moons, the Saturnian system, and the images and the data that are being sent back across 1.3 billion kilometers of space between us and Saturn. It's an immense amount of space, and we're looking at these images and getting an idea of how this planet and its system may have formed, how it may continue to evolve and change, and maybe we can get some ideas about how our own solar system came to be out of looking at it. So without further ado, I'd like to welcome Dr. Lopes. Thank you so much for joining us.
Oh, it's a pleasure. Thank you so much for having me on the show.
I'd love to know, just to start right off the bat, you've said before in other interviews that you wanted to study volcanoes and the Earth, be a volcanologist or a geologist since you were about 5.
That's right. Well, first of all, I wanted to be an astronaut.
Okay.
But I come from Brazil, and when I was growing up, there were not many Brazilian astronauts. In fact, there were not any. And women astronauts were almost non-existent.
Right.
And the worst thing is that I have very bad eyesight. I wear contact lenses, and so I realized that that wasn't going to fly. So I decided to help in space exploration another way. I decided to become a scientist and get involved in the exploration of space. And what I do is the unmanned exploration. So I work with robotic missions to see the wonders of the solar system through spacecraft eyes. And that's been very exciting.
Yeah, has the advancement of technology and the advancement of robotics, I mean, in the years that you've been working on studying our own planet, and also you studied Mars, you've studied the moons of Jupiter, Io, now Saturn. Over the years, has the advancement of technology really allowed you to see more and do more?
Oh, yes. The advances in technology have been amazing. And for Mars missions, for example, we're getting resolutions. You can see detail on the surface now of inches now. And when I was studying Mars back in the old days, from Viking data, what we have was very inferior, but it was still fantastic for the time. So, of course, the technology gets better all the time. One thing we have to consider is that the missions we have flying now are not using the latest technology because it takes quite a bit of time for a mission to be built. And also, we don't want to risk using a technology that we're not totally sure about.
Right. You don't want to beta test on your
That's
on your
right,
mission.
exactly. You don't want to beta test on your spacecraft.
Right.
That would be a very expensive test if it went wrong. So we fly what we call space qualified kind of technology that is ready for flight. It's still new, but it may not be the latest that you might have here on Earth.
Right. What do you think is the in terms of looking from your work studying Mars to now studying Titan and working with the Cassini mission? What is your favorite piece of technology that you're working with or that you have worked with?
Well, that's hard to say because I have worked with several different instruments. My work on Mars with data from the Viking mission was with images. And then I joined the Galileo mission and I worked with an infrared instrument called the near-infrared mapping spectrometer. And now on Cassini, I'm working with radar. So I keep changing wavelengths as well as changing missions and changing planets. So It's hard to kind of pick a favorite. But what I can say is that Cassini is by far the largest, is the most complex mission ever flown. We're doing so much of Cassini that it's hard for anyone, I think, on the project to really keep track of it all. There are many disciplines, many different types of scientists, people studying the atmosphere of Saturn, the rings, the magnetospheric environment around Saturn, people studying the moons, and then people studying Titan in particular. So there are many people all over the world, in fact, on the Cassini mission and studying this data.
With the Cassini mission, are you ever, there are all these rings around Saturn. It's got lots of moons. It seems like there are lots of potential objects for Cassini to run into. Has there ever been an issue with worrying about that?
Well, actually, when we first did the orbit insertion around Saturn, we were quite concerned about that. And because we had to cross what we call the ring plane. So Cassini had to fly through the ring plane, and it was a quote, empty part of the ring plane, but you never know if it's completely empty. And we had to do that twice. So we kind of, we're a little nervous about that. We, did all the studies and we thought everything should go just fine. And it did go just fine, but there was always that little risk. And what we did was to put the main antenna in the direction of like the flight path so that would protect the most sensitive instruments to some extent. So it was a little mitigation there of the danger, but it was still a huge relief when we found out that everything was fine. Yeah,
I imagine. It would probably be something akin to like holding an umbrella in front of you as you walk through traffic. Stop.
Yes, well, that's a good analogy, but traffic was very light that day.
That's good. So your specific interest is you're looking at Titan and the geology of Titan. Can you tell us, using radar, what you've started to see and what you've really been starting to learn about this particular moon?
Well, Titan is a very interesting moon. It's the second largest moon in the solar system, Ganymede around Jupiter being the largest. And these are really planets in their own right. We call them moons because they are around bigger planets, but Ganymede, for example, is bigger than the planet Mercury. So these are our real worlds. And Titan is very interesting amongst all the moons of the solar system because it has a substantial atmosphere. And in fact, it's the only moon of the solar system that really has a substantial atmosphere. Now, that makes it very interesting for atmospheric scientists, but also for geologists, because what we see is the interaction between the surface and the atmosphere very much in the same way that we see on Earth. Titan has winds, Titan has rain. Titan has dunes formed by wind, and rivers and lakes carved by rain. Only it's not water rain, it's methane rain. So it's a place very similar to Earth geologically, but also very different because of the composition, because the temperatures are so much colder, and so on. But for a geologist, it's really been totally fascinating, and I can tell you a little more about the things we have been seeing.
Yeah, please do. I'm interested. I mean, the dunes, and I've seen pictures as well. There's a wonderful library of images that you sent a link to, that hopefully we can get into some of those images eventually. But the canyon, there are canyons on Titan. I'd love. Tell me more.
It's when you look at any planet, any solid planet or moon in the solar system, you always find that there are four major geologic processes, and it's how these processes interact with one another that really shape the surface and tell you what the surface is going to look like. So there are two internal processes, which are volcanism and tectonism, so mountains being formed and volcanoes being formed, and flows, volcanic flows. And then there are impact craters, and also erosion. And erosion can be by wind, by water, for example. The Earth suffers a lot of erosion because of water. And on Titan, we see all this process is really going on and competing. While if you look at the Earth's moon, for example, you see a lot of impact craters. But you don't see erosion in the same way that you see on Earth. There's no atmosphere, so you don't see wind, erosion by wind. You don't see erosion by liquids. So you see that's why the surface of the Earth's moon looks so different from the surface of the Earth or the surface of Titan. Right. It's just how these processes operate together and how they compete with one another. Now, Titan, our biggest surprise was that we expected to find quite a number of impact craters, and we have found very few. If you look at the other moons of Saturn, they have a lot more impact craters. And what happens, this is telling you that the surface is very young, because we know that closer to the time when the solar system formed, there were lots of small projectiles around impacting into those moons and forming craters. Now, Titan had something or some processes that actually wiped out a lot of those old impact craters. And these processes have been, mostly probably volcanism and erosion. Erosion by the methane, the liquid methane, wind may have played a part. We also may have had like hydrocarbons falling down from the atmosphere and settling on the surface and covering up those craters. So that was a big surprise, was to find few impact craters on Titan. So we knew immediately that the surface was quite active.
It's so fascinating, too, because before the Cassini mission and the Huygens probe, Huygens, thank you. Before the probe, the atmosphere is so thick and dense, you really had no idea of what was underneath it, right?
That's right. And that's why Titan has been so amazing to explore, because we had some infrared images from Earth that gave you some shapes, some ideas. Like we knew there was an infrared bright region called Xanadu near the equator. But yeah, that's right. The names on Titan are wonderful, actually. A lot of names of places of enchantment.
Yes.
And so, we had very little idea about the surface. And that's the great thing about radar, is that radar can penetrate that atmosphere and that haze and see the detail, the geologic detail on the surface. And that's actually why I chose to work with radar, because for geologists, that's actually the best instrument. Other instruments can see through to the surface as well, but radar gives you the most detail.
The highest resolution. Someone in the chat room here is asking what does a young surface mean in terms of a timeline? So if you could give us some frame of reference.
Well, yes, that's arguable because the only place where we really have data points for is the moon that we actually really know. For sure, the Earth's moon. We had samples brought back and so on. But for other places in the solar system, we have to do calculations based on what you thought the influx of material was forming these craters. So, I would say the surface is younger than about 1 billion, but we don't have, a great, estimate. And of course, that's on average, because in some places the surface is extremely young because there are processes that still go on. And volcanism may be one of these processes that is still going on. And lakes certainly, are another process that is still going on. We have, we see lakes, particularly in the polar region.
These aren't water lakes.
No, they are liquid methane and probably ethane as well. Wow. So Titan is very similar to the Earth in terms of the geologic processes, because as I mentioned, you have the atmosphere, you have dunes, you have wind, volcanism. You're showing here right now an artist's representation of a region known as Hote Arcus. And this was done by Michael Caro, a space artist. And we think what's going on in this region is a lot of degassing. And it's been a really fascinating study that I've been involved in between two instruments on Cassini. The infrared instrument on Cassini, called VIMS, actually detected some brightness changes over this region, but they couldn't quite see through to the surface to see detail on the surface. And so, they were saying, well, there are these brightness changes and they could be caused by volcanism. Maybe some degassing, maybe a frost being deposited because of gases coming out of the volcanic region. And then we looked at this region with radar and actually saw flows, a flow morphology. So we can't absolutely prove that there is active volcanism going on, some kind of active volcanism, but we see flows and we see this brightness changes. So it's two good lines of evidence that something may be going on. So Titan may still be active in terms of volcanology, and it's going to be fascinating to get more data and see if we can really nail this down.
Yeah. Is it the same kind of volcanism as we have here on Earth, or that at one time existed on Mars? I mean, is this something that's consistent throughout planets and moons of the solar system?
No. Actually, on Titan and the moons of the outer solar system, the icy moons, we have what we call cryovolcanism, and that is a very cold volcanism. And what happens, instead of the material erupted being liquid rock, that's what we call magma on Earth, and once it comes out, it's called lava. The material in these icy worlds is actually water that is underneath an icy crust. So you have icy crusts on moons like Titan and Enceladus, and then Europa, which is a moon of Jupiter. And then underneath these icy crusts, you have a layer of liquid water. And on Titan and Enceladus, we think it has ammonia as well. And this mix can erupt at the surface and come out as a kind of slushy ice. In fact,
slushy eruptions.
Yes, exactly. And so they are icy eruptions. They are not liquid hot rock eruptions like we have on Io and we had on Mars in the past and we have on Earth. So from a volcanologist's point of view, well, they are fascinating because they're different, but my favorite eruptions are still those of Io, one of Jupiter's moons that has the most spectacular rock eruptions of the solar system.
Wow. It's such a different thing to think about, trying to wrap your head around, instead of being earth and magma and heat and rock and, the way that volcanic eruptions occur here on our planet. Just think of it as, like you said, an icy crust with a water slushy underneath that's mixed with these other compounds. And it's a completely different, I mean, I almost wouldn't want to call it volcanism, but I guess.
Yeah, in fact, I recently wrote a paper about exactly that, is how we need to redefine volcanism now that we have found all these strange places with these things that colleagues of mine would say, but can we really call these volcanoes? And then how do you define what is a volcano? And you have to define it in terms of what is the, quote, magma for that planet. So on Titan and Enceladus, the magma would be water with, perhaps some ammonia or methane in it, but that would be the magma. That is what's underneath the crust. While on Earth and on Io, the magma is molten rock. So depending on what planet you're dealing with, the magma is going to be different. But the process, which is a process that is bringing material from the interior to the surface, that's still volcanism.
Right. Yeah. So there's a mixing. There's some kind of dynamic flow beneath the surface that's bringing things up to the surface and releasing.
Right. Yes. So it always stretches your mind, and if you only ever looked at the Earth, there is so much that you wouldn't know. Even impact craters, for example, that's a great example, because you look at the surface of the Earth and there are very few impact craters, and relatively few, and very few that you'd actually recognize as impact craters. And while you look at the surface of the moon, and there are lots of impact craters because the moon's surface has preserved those craters and the Earth's surface hasn't. But it was really only when we started to look at the moon and other planets that we understood the importance of impact craters, impact cratering as a process, and how it may still go on, and actually that there is a real danger to the Earth from an asteroid impact.
Yeah, and we just saw that a few months ago. Wasn't Saturn hit by
Jupiter? Yes.
Oh, it was Jupiter. Okay, sorry.
Yeah, and that's right. And by looking at these other planets, we also saw years ago the Shoemaker-Levy 9 comet impact Jupiter, and now we saw another one, and so we know that these things happen fairly frequently. But if you're only looking at the Earth, you would miss a lot of how important some of these other processes are.
Yeah, has it really influenced our understanding of geological processes here on Earth to actually be looking at them on other planets, other moons in our own solar system? I'm just thinking of the characteristics of water flowing through land or of impact craters. Satellites really only started looking back on our planet very recently, as well as looking at other planets. So is that influential?
Oh, absolutely. Yes. It's just the fact that we can look at the Earth from space now and map so much more and connect the processes so much more, and then compare them with what's happening on other planets. And we are now really understanding how these major geologic processes interact and how different conditions make them interact different ways. And what forms different shapes. For example, an impact, if it's an impact on ice or rock, the shape of the crater and the ejecta around it is going to be different. And same thing depending on the composition of the volcano, the shape may be different. And of the lava flows or the cryovolcanic flows. And actually an interesting thing about these icy volcanoes is that if you have mixtures like icy slushes with ammonia, the let's say what we call the rheology, which is it's like the viscosity or how this material deforms, can be very similar to that of a basaltic lava. So you might end up with a flow that looks very similar to a basaltic lava flow on Earth, but it's actually an icy flow.
I'm imagining many experiments at 7-Eleven taking place after.
Right.
Slushies.
Yeah, in fact, one of my colleagues here likes to joke with me about slushies. Yes, I do experiments with slushies.
If you could only get methane slushies, then you'd really be going. Yeah.
Then you'd be doing it right.
So next time you get your slushy, just think of icy volcanoes on Titan.
Yeah. Wow. Is there still a lot of debate within the geology community, the volcanology community, about different characteristics of land flows, of these, of characteristics of, say, Titan versus the Earth? Are people still hotly debating these things, or are characteristics you look down and you go, oh yeah, that's pretty much what that is?
Well, I wouldn't say it's hotly debated, because there are some things that are pretty obvious. You look at one of those radar dark lakes on Titan, and there are lakes. We did have some issues about whether they were really liquid, because the evidence pointed to liquid, but we actually got data from another of the instruments, VIMS in particular, which is the infrared instrument, and recently it actually saw what we call a specular reflection. So that's another line of evidence that they are liquid. Sometimes it's hard to actually prove something. The evidence all points to the fact that these lakes are liquid, but it might be hard to actually prove it.
Is that because there's not a spectrometer in Cassini?
No, we do have a spectrometer, and it was the spectrometer VIMS that eventually actually found a signature of liquid ethane in one lake, and then saw a specular reflection on another lake.
Really? Wow. There are hydrocarbons
often,
in there. That's amazing.
Yes, yeah. We often use these experiments, these instruments together, and we use we combine the data, and so you get one piece of evidence from one instrument and another piece from another instrument. So that's the beauty of a mission like Cassini with many instruments. But there are some things that are debated. Well, some of my colleagues, actually, a few of my colleagues think that maybe the volcanic features we see might not really be volcanic, that they might be erosional features or fluvial deposits. And, and I don't think so, but they do have a valid point of view. We haven't completely nailed that yet.
Right.
And the active degassing of volcanism, we haven't really nailed yet. There is some compelling evidence, but I would like actually to see a thermal signature that an active flow was actually warmer than the surroundings. That would really nail it.
Yeah.
And there are some features that we really debate because our resolution is not actually really good enough sometimes to tell what the feature is geologically. Yeah. And we with radar, we get resolutions of between like 350 meters to 1.5 kilometers, 2 kilometers, and that's often not quite good enough to really tell what's going on the surface. So we make educated guesses, you can call them. Yes.
Now it's too late. Cassini's done, right? So you're not getting any more images.
Oh no.
Oh no. Okay.
We are on the extended phase of the mission.
Yeah, it was supposed to be just a 4-year tour, but now it started in 2004. It's now 2010, and it's
isn't
still
that great?
going.
NASA's so good at keeping stuff going. I love
it.
Well, we hope so. We know it's going to keep going until at least later this year, and we have asked NASA for money to and support to extend the mission until 2017.
Wow.
So let's see if that's approved. But
so are you hoping you
great? So.
Are you hoping you could see an eruption? I mean, obviously that would answer so many questions.
Oh yes. I mean that would be amazing.
Is there a chance of that, do you think?
Well, there is a chance. I think we would need to be lucky because, for a start, you fly by Titan, once every few weeks, and you're not always using For example, the radar experiment or VIMS, that's the spectrometer that could actually give you let's say if there was a thermal signal that could detect it, you'd need to be looking in the right place at the right time. And the chances of that are not great. I mean, if we were around Io, which has volcanoes that erupt all the time, all over the place, it would be easy. But, Titan, we know that if the eruptions are still going on, they are rare. So we would need to be lucky. But another thing we could see is a surface change. If there is one of these areas that we think are volcanic and has flows, and we saw it in, let's say we had seen it already in one flyby, and then we had another flyby of the same region, and we found out that the flows had changed, then that would tell us that something was going on. So that would be great too. And we might see other changes, like we might see changes in the dunes. So that would be very exciting.
Yeah.
So there is, and we're still seeing new territory because we have not mapped the whole of Titan yet, not by a long way. So there is always something more that's new and exciting to see.
I think that's absolutely exciting. Is looking at stepping away from Titan for a second and looking at the entire Saturnian system. I mean, we've mentioned that that it's good to look out from the Earth and look at the entire solar system to kind of get an idea how things work here and in conjunction with everything else in terms of, say, solar system formation. Is it possible to look at Saturn with its rings, with its many moons that are little planetoids, to look at that as, say, a model of solar system formation and make guesses as to how our own solar system formed?
Well, I think that there is some connection, certainly, because the formation of the Saturn system is a big and important piece of the formation of our own solar system. And the Saturn system is very interesting. For a start, it's the only system with a really major ring system. It has the major ring system. And so the ring scientists have been extremely busy actually looking at the interaction between the moons and the rings.
Yeah.
For example, Enceladus, which has active volcanism, has actually these plumes that we see going into space. These plumes are creating and feeding one of Saturn's faint rings called the E ring. And that was suspected before Cassini because Enceladus is right in the middle of this E ring, but it really was with Cassini and particularly the discovery of volcanism and of the plumes that we really nailed that. And then there are all kinds of fascinating things about how little moons can interact with the rings and shepherd the rings. And so there are all these kinks and spokes and weird things going on. Which are really fascinating, and people are trying to figure out the age of the rings, and we know the composition pretty well. It's nearly all water ice with some dust. And then there's dust around in the system that seems to be able to go from perhaps some moons to other moons. So people are looking at the composition of the surface of different moons and finding connections between them. And there is Saturn itself that has an amazing atmosphere and some mysteries such as this hexagon near the northern polar region that people haven't figured out yet how it forms. So the atmospheric scientists are really interested in studying Saturn. So there are a variety of disciplines, and as I said, it's a very complex mission because of that.
And your next mission is the New Horizons mission that's going to be going out to look at Pluto, right? Is that exciting for you to be going out even further?
Yes, that is already on its way. And in fact, I collaborated with the team when they did their Jupiter flyby a couple of years ago because they took some data of Io. which is, close to Titan. Titan and I are my favorite moons. And, it's like having two children that you really love, and it's hard to say which one you love the most.
Which is my favorite moon.
Which is your
Yeah,
favorite?
that's right. My favorite moon, yes. They're very different, but both very exciting. And so I collaborated with the team on their Jupiter flyby, and that was very exciting. We did find a new volcano on Io, so a new active volcano. So that was interesting, and we saw an eruption in a place where we had seen eruptions before, but it had a huge plume going up more than 400 kilometers. So it was very spectacular. So now it's on its way to Pluto, and it's going to be fascinating to see what we find at Pluto.
Yeah, I'd love to. I can't wait to see what we learn about it. It's, the furthest, now no longer a planetoid. Pluto.
Dwarf planet. Yes.
But at least Eris is a phone now, so that's good,
Eris
right?
is a
phone
planetoid.
and a planetoid, yeah.
That's right.
Yeah. Right. yes. That was it's always an interesting debate, but New Horizons is going to the Kuiper Belt, which we now consider like the third zone of the solar system. You have the rocky planets, and then the gas planets, and then the Kuiper Belt and the dwarf planets there. So it's going to be the first spacecraft to really explore close up and personal Kuiper Belt objects.
Yeah, I can't wait to hear more about that as it gets out there, and I'm looking forward to the news.
Right. I know it's working well.
Yeah. Well, thank you so much for your time today. I know you have a very tightly packed schedule, so I do appreciate the time that you've taken to speak with us.
Great subject, though. I just love it.
Yeah, it's so fabulous to learn about our solar system. I think one final question: if you look at volcanoes here on the planet, you look at volcanoes elsewhere, what's your favorite? Do you want to just keep looking out to the stars?
Yes, I like learning about volcanoes everywhere on Earth and other planets, and I started out studying Olympus Mons, which is the largest volcano in the solar system. So
that's on Mars, right?
That's on Mars, yeah. So maybe I got a little spoiled starting with the largest, but it wasn't active. And then I had this very exciting period working on the Galileo mission, in which I discovered 71 unknown volcanoes, active volcanoes on Io, and it was great. Here found another one and another one, and I still love volcanoes on Earth. I say that I need to go to a volcano on Earth at least once a year.
Isn't that dangerous, though? Aren't you worried about getting erupted upon?
Not if you know what you're doing, and it depends on the type of volcano.
Right.
Some volcanoes are very dangerous. Some are. Really.
What's your favorite Earth?
dangerous.
What's your favorite Earth volcano?
My favorite Earth volcano, well, for the last few years, I would say it's been Kilauea in Hawaii,
Right.
because it's so active
Right.
and so beautiful, and I have seen such beautiful things there. And it's also easy to get to,
Right.
and
Right.
easy to get around. There are some places that takes you a lot longer to get to, but there are a lot of fascinating volcanoes on Earth, and maybe we can talk about them some other time.
Love to.
I
Dr.
hope we
Lopes has a
can.
great series of books, The Volcano Adventure Guide and Volcanic Worlds, and EO After Galileo. So this is great. And you're doing a new one called Alien Volcanoes, or is that out yet?
That's out. That's out.
That's great.
And,
That's
yeah,
great.
and I'm doing a new one called The Beginner's Guide to Volcanoes that's just in press now. So,
Kids love volcanoes, don't they? There's
Yes,
something
they
about
do.
it's a great way to get kids started with science, I think.
It is, because kids love space, volcanoes, and dinosaurs.
Exactly.
So at least I did
That's
two
good.
out
One,
of the
two,
three.
three.
Yeah.
I don't do dinosaurs, but I do the other two.
My dad did dinosaurs, but I love volcanoes in space too, so that's really neat.
Well, thank you once again, Dr. Lopes. It's been fabulous to be able to speak with you, and I do hope that we can get you on the show again, because this topic of volcanoes is wider, and definitely there's a lot more to uncover, and so we'd love to speak with you again at some point in the future. But in the meantime, good luck with all the work that you're doing, and thank you so much for your time.
You're very welcome. Thank you.
Thanks for joining us. Take care.
And if anybody out there would like more information on the Cassini mission or Titan or any work that NASA JPL is doing, JPL has a Twitter feed at NASA JPL, so at NASA
I think you can
JPL.
put out if you want.
Cassini has a Twitter feed that's at Cassini Saturn. And the JPL, NASA JPL, has a Facebook page, so you can be a fan of JPL and find out what missions they're working on. It's facebook.com/NASA JPL. And the Cassini mission to Saturn has a webpage, saturn.jpl.nasa.gov. And there you'll find links to all sorts of amazing content, the image galleries of all the moons of Saturn, Saturn itself, Saturn's rings. There's a lot more to explore out there that we've only touched on the surface.
Oh, yeah.
Titan was just one small part of this entire project, and I love the fact that we are exploring our solar system and sending craft out where man cannot yet go. I think right now, especially, it's questionable where our governments are all undergoing.
We're so broke.
A wallet pinch.
Yeah.
It's time to
But
pinch
it's
our
so
pennies.
worth it. I mean, and boy, we learn so much about ourselves from this stuff.
We do. We learn so much about ourselves, and I believe it also gives a certain amount of that spirit of adventure and hope, and that thinking of the future and all the things that humankind can possibly do. It really gives you a sense of all the possibilities. So every time I look at stuff like this and I get to talk with somebody who works in astrobiology, cosmology, any kind of space physics, I just get goosebumps talking to them because it's so fascinating.
And I love JPL. I mean, they're the ones who did, of course, the Phoenix, and they just really have such an incredible track record.
They do.
Oh, that's a picture of the Phoenix. No, I was going to pull up the
of the Phoenix.
NASA JPL site where you can follow them, and they have a list of sister accounts on here on Twitter as well. So.
Yeah, it's absolutely great. There's a lot of stuff out there, and Rosaly is working tirelessly to tell us all about volcanoes. I'm still working on confirming next week's guest, but if he is confirmed, we will be talking about dinosaurs.
Yay!
So we're
Well, you got the
for
trifecta.
The trifecta.
Yeah.
Space, volcanoes, and next week dinosaurs.
Yep.
The idea is that we'll be talking about the trimming of the dinosaur family tree next week.
Yeah, it all changed from when I was a kid.
It's all changing right now.
Yeah.
So there's
I memorized all those long names, and now they're no good anymore. None of them.
and now they're just hacking dinosaur species out of the list.
Worse than Pluto.
You
I mean,
don't
that's
belong
nothing
here anymore.
Brontosaurus gone.
Triceratops.
No. They can't
kidding.
get rid of Triceratops. That's the
They
cool one
won't.
with 3 horns.
Well, it's interesting. There have been many splits of subspecies or different species of the Triceratops family. That they have said, okay, well, the horns are different, the frill is different. We're going to give it a different name, and
They're like dung
now
beetles.
They're looking back and they're going, oh, maybe that's just an immature.
Right. Maybe they grew.
Triceratops. Maybe it grew. Yeah. So there's a lot of information that's coming out right now that's fascinating, and paleontologists are getting all the fun digging in the dirt. So until next week, though, I am Dr. Kiki, and this has been Dr. Kiki's Science Hour. You can find me online at drkiki.tv, or you can listen to my other science podcast, This Week in Science. You can go to thisweekinscience.com to find that. And you can tweet me on Twitter at drkiki. And it's been a lot of fun. So until next time, keep looking upwards.